Okay, so I'm going to make up a problem like, we're not going to do 21 yet. I'm just going to make up a problem, okay? And then we're going to hit number 21. There's only 4 that we're going to do together. So if I gave you, what do they give it to you? They give you the 2 functions. If I gave you something such as this, 5x to the third minus 4x squared plus 8x minus 9, and you're going to divide that by x minus 3, okay? And again, I misspoke yesterday. I was thinking that I taught you guys this in Algebra 2, but it was during the lockdown. I know I taught it in Algebra 2 last year, but you guys had Algebra 2 2 years ago, and it was at the end of the year, and we got locked down, and that's when I didn't teach it during that time. I skipped over it. So here's what you do with synthetic division. And again, you're going to like this. There's some real simple explanations behind this, okay? You draw a little box, okay? And I'll just watch. I'll give you time to copy it all. It's going to take you 20 seconds when you're all done to copy all this down, okay? You draw, and it's only half of a box. That's just the way you do it. Okay? I mean, if you want to draw a whole box, I guess you could, but every math book I ever saw, they just put a half of a box there. And on this particular problem, I'm going to put positive 3 in the whole box. And then on the top line, you put, in this case, 5, negative 4, 8, and negative 9. Any idea where I got all those numbers from? In the box is the opposite of this, good. And where do these numbers come from? Those numbers, 5, negative 4, 8, negative 9. Basically what we're doing is division, like what we did yesterday, but we're leaving the variables out for right now. For right now, we're leaving the variables out, okay? They'll eventually come back, okay? And then what you do is this. We have the top line right here. We have a second line. I'm going to leave a space here. We're going to put some numbers in right here, okay? The next thing I do is so easy that some students struggle with it, okay? It's very, very simple. You don't think hard on this at all, okay? First thing I'm going to do is I'm going to put a number right here. In this case, I'm going to write 5. Any idea how I got that? Where that 5 came from? What's that? Who's talking?
I just said physics the first one.
Yeah, you know when you do this 5? You just drop it down. That's all you do. Some students say, well, did you times by 1? You could, but when you times by 1, you know what you're doing? Nothing. You're not doing anything, okay? Now, the next number, I'm going to write numbers here, then here, then here, then here, in this order. They're going to kind of ping pong back and forth, okay? The next number I'm going to write is 15. Now, I did something here. Nothing major, but I did something. It wasn't really...
In the box, but the first number?
This is the magic number. Take this number times that to get this, okay?
Oh.
Next number I'm going to write is 11.
I'm pretty sure you taught us this.
I feel like
I remember this now.
You should remember the little box thing. I would have thought you'd remember that.
No.
Where'd the 11 come from? Negative 4 what? Plus 15, right. Next one I'm going to write is 33. Where'd that come from? 11 times the magic number. What's the next number I'm going to write? Careful. Where did this 11 come from? What do we do with these? Added them. Not subtracted, we added. 41.
Oh, so
You
the
multiply,
five-
add, multiply, add, multiply, add.
So
Over and
wasn't
over.
the 5 you're really like 5 plus 0, but since the 0 just drops on 5? Because there's no number underneath it? While the rest of you're adding whatever number's underneath it?
Oh, maybe. Nobody's ever brought that up. Yeah, it could be. I just always, every math book I ever saw, it just it draws a little arrow and says drop it down. Okay, next one I'm going to write is 123. 41 times 3. Then we're going to add these and get 114. And we're almost done. This problem's almost done. What you need to understand is this. Think of it as like if you work a cash register, like the till. You have like your 1s, your 5s, your 10s, your 20s, and so forth. Each tray represents a different thing. This last tray is the remainder. Okay? This right here is your number, just your number. This right here would be your x's. This right here would be your x squareds. If we had one more in the till, these would be your what? x3s, another one would be x4s, but we didn't go that far, okay? So you have your remainder, then just a number, then your x's, then your x squareds. So, put it all together. How many x squareds do we have? 5 of them. 5x squareds. We have 11x's, not negative 11x's, so we put plus 11x. Plus, because it's not negative, 41, it's just a number. You don't put the x with it, so 41. And this is not negative, so plus 114. Now be careful, over what you were dividing by. What you were dividing by originally. What were you dividing by originally? X minus 3. Okay? And that problem's done. Now, practice yesterday. I'll tell you what, pay attention right now. All of you pay attention, but especially you. This is what you missed yesterday. If I was going to do long division, we would have had x minus 3 goes into 5x3 minus 4x squared plus 8x minus 9. Okay? Let's just practice from yesterday, okay? Because again, I'm going to give you more problems like this, a few more like this for your worksheet. How do I make x 5x3? What do I times x by to make 5x3? 5x2. And then we times each of these by 5x2. 5x2 times x. 5x2 times negative 3 is negative 15x squared. Then what do we do? One word. You know what we do next? Subtract. What's 5x3 minus 5x3? That's gone. Negative 4 minus minus 15. Minus minus is plus plus. So negative 4 plus plus 15, which is 11x squared. Drop stuff down. Then we repeat it. How do you make x 11x squared? What do you times x by to make 11x squared? Positive 11x. Times each of these by 11x. 11x times x. 11x times negative 3. For the second time you subtract. These cancel. 8 minus 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 plus plus 33. 8 plus 33 is 41x. Drop to minus 9. One more time. How do you make x 41x? Times by 41. 41 times x. 41 times negative 3 is negative 123. We subtract again. 41 minus 41 is gone. Negative 9 minus 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 is plus plus. These add up to 114. That's your. How do you make x 114? Can't. So that's your remainder. So plus 114 over x minus 3. Same thing. So synthetic a little bit nicer, a lot less work. So why don't we just always use synthetic? Real simple response. You can't always. Synthetic's nice because it's so much easier. You can't use synthetic all the time. I'm curious if you guys can figure this out. The only ones you could have used synthetic on, the only ones on numbers 1 through 8 you could have done synthetic on is number 7. That's the only one. Any ideas why? And it's okay if you can't. Tell you what, if I would have changed this right here to x squared, you can't use synthetic division. It doesn't work. You have to be dividing by a polynomial of degree 1. It's got to be degree 1. So you look at numbers 1 through 8. See, look at number 1. You're dividing by x squared minus 3. If it was x minus 3, you could use synthetic on number 1. Number 2, you could have used synthetic. It was x plus 1, not x squared. It's got to be degree 1. Okay? So when you're looking at 21 through 28, you're always dividing by, like number 21, you're dividing by x minus 2. That's first degree. 22, x plus 4, that's first degree. It only works for first degree ones. Okay? So that's, again, it's nice because it's so much easier. But it stinks because it doesn't always work. Okay? All right. Question on that? So look at number 21. There are a little bit tricky questions on 21. They're not. They're kind of tricky. Some of them are. The first one's not. Okay, what goes in the little box? Positive 2. And when you're doing synthetic division, you better not write down any variables until the very end. You don't put any variables down unless you write the problem down. Okay, you don't write any variables, no x's until the very end. And then my top line is going to be 2, negative 3, 4, negative 5. We just take those numbers, write off what we're dividing into. What's the next number I'm going to write? Mike, is this 2? This 2, we just drop it down. Do you have to draw the arrow? No, you don't. I do, but you don't have to. What's the next number I'm going to write? Where'd 4 come from? 2 plus 2? 2 times 2. 4, and what? Add the 1, times the 2, add the 6, times the 12, add the 7. What is 7? The remainder, what's 6? The number, what's 1? X and x squared. What's your final answer? 2x squared plus 1x, or just plus x, plus 6 plus 7 over, what were we originally dividing by? X minus 2. Was I being sarcastic yesterday when I said that you guys are going to love this? Seriously, this is great stuff. Compared to this, oh man, this is, would you agree? I actually had some students say they prefer doing this. I think they're nuts. I don't know. They were being, I don't remember who it was, but it was a couple of years ago, and they were being, they're good actors or actresses if that's the case, but I don't know how you can like that better. I hate long division. 23. Okay, 23. I told you that some of these are a little tricky. This one's a tricky one, okay? So what goes in the box? -3. Top line, what's the top line? 1, then what? Good. She's on the ball. How come 0? You need a placeholder. There's no x squareds. If you don't put the 0 in, you will get the wrong answer, okay? So 1, then there are no x squareds. Then do I get to put the 8? -8. And then -5. Drop the 1. Times 1 and -3, you get -3. Add 0 and -3, you get -3. Times -3 and -3, you get +9. Add -8 and +9, you get 1. Times 1 and -3, you get -3. Add -5 and -3, you get -8. That's your remainder, that's your number, that's your x squared. Your answer is x squared minus 3x plus 1 plus -8 over x plus 3. I don't care if you say plus -8 or if you just want to say minus 8. I don't care. It's the same thing. Okay, that last question was tricky. This one's even a little more tricky. Okay, same basic concept, but it's a little more tricky. 25 in the box is -2. Occasionally I'll have a student will say, what if I forget to put the opposite in? What if I put the actual number in? Well, you're going to get it wrong then. Okay, it's always the opposite. It's always the opposite of what's with the x. Top line is going to be 3. Then what? 0. Then what? How come another 0? There's x to the 5th. There are no x4s. There are no x3s. So I need another 0? Right now I need another 0? Right now after the second I need 3 zeros in a row? No, actually I have no x4s, no x3s. I do have an x squared. -6. Then 15, then 7 or not? No, a 0 because there are no x's. And then 7. So 3, 0, 0, 6, 0, 7.
Wait, why is it -6?
Because I was looking at number 24. For a second, I kind of was doing 24 and 25 at the same time. Good question, thank you. So do I have them all right now? 3, 0, 0, 6, 0, 7. Okay. So top line is going to be, or drop it to 3. 3 times -2 is -6. Add 0 and -6 is -6. Times -6 and -2, it's a +12. Add 0 and 12, we get 12. Times 12 and -2, that's a -24. Add 6 and -24, that's a -18. Times -2 and -18, that's a +36. Add 0 and 36, we get 36. Times 36 and -2, that's a -72. Add 7 and -72, that's a -65. -65 is our remainder. 36 is our number. -18 is our x. 12 is x squareds. -6 is x3. 3 is my x4s. So the answer should be 3x4 minus 6x3 plus 12x squareds minus 18x's plus 36 plus -65 over x plus 2. So that one wasn't any more difficult, it just took a little longer. $27. in the box is a positive 1/2. Top line is going to be 4. Then 0, because there are no x3s. Then -5. Then 0 again, because there are no x's. And then 1, positive 1. Drop the 4. Half times 4, half of 4 is 2. Add 0 and 2, we have 2. Half of 2 is 1. Add 1 and -5, that's -4. Half times -4 is -2. Add 0 and -2, you have -2. Half times -2 is -1. Add those, we get 0. So it's the first time I had something like this. Our remainder is 0. Our remainder is 0. So there's no remainder. That's our number, that's our x, that's our x squared, and that's our x3. So the answer is 4x3 plus 2x squared minus 4x minus 2. And you don't need to say plus 0 over x plus x minus a half. I mean, you can if you want. But, I mean, it's not like if I was to ask you what is 10 divided by 2, you don't say 5 remainder 0, you just say 5. I mean, it's not wrong, but it's kind of pointless. You don't need to, if there's no remainder, you don't need to say there's remainder. We good with this? So let's do this. It's up to you. Like I say, Monday's going to be a work day. What I'm going to do, though, is I'm going to give it to you on Monday. If you want to work right now, you can. I don't really care. If you want to just kind of kick back, you can do that as well. But on Monday, you need to fill in the evens that we skipped. Plus, I'm going to give you probably, I would say, 3 long division ones also that I want you guys to do as well. Okay? So, all right, rest of the time's yours, guys.